For this video, I am going to create a function that will reverse the order of our linked list. On the right hand side, if we look at our heap, we have 4 nodes. At index 0 we have 10, at index 1 we have 20, at index 2 we have 30, and at index 3 we have 40. So let me compile this for you to show you what we have. So here at index 0 we have 10, index 1 we have 20, index 2 we have 30, index 3 we have 40. The goal is to reverse the linked list to where this becomes index 0, this becomes index 1, this becomes index 2, and this becomes index 3. We also want to reverse where our arrows for our next pointer are pointing to. So for example, this node that hosts the data 10 is pointing at the address 0x200, and this node with the data 20 is pointing at 0x300, and this node with the data 30 is pointing at 0x400. Finally, this node that holds the data 40 is pointing at null. What we want to do is we want to reverse that. We want this to point to null, and we want this node to point here, and this node to point here, and this node to point here. So when we print it, index 0 should be 40, index 1 should be 30, index 2 should be 20, and index 3 should be 10. So we should be getting a reverse printing of this, 40, 30, 20, and 10. Let me erase the red ink so I can go over the logic. I did keep the indexes because this is how we want to reverse it. We want to go the opposite. I'm just going to abbreviate our pointers, H for head, C for current. Head and current will both be pointing at our first node of the list. In this case, 0. The blue indexes our current list. What we want to do is we want to traverse head all the way to the last node. So head should be pointing at index 3, and by the time it points to index 3 will become index 0. But we also want to have this first node pointing at null. But if we have this pointing at null, we are going to break this link. So we don't want to break that link without moving head. So what we want to do is we want to move head to the next node and leave current where it is. So let's go ahead and start coding. First, I am going to create a function prototype. And for this function prototype, we're going to have the data type node, and we're going to call it reverse list. And we are going to use a call by address. So this is going to be a node, and we're going to use a double pointer head. Let me copy this, put it at the bottom, and create a definition for it. So the first thing that I want to do is I want to create the pointer current. And current is going to equal head. And don't forget to put the asterisk in front of head because we have a double pointer that's pointing to a single pointer. So let's go back to the picture and let me erase this. So what we want to do is we want to take this first node and point it to null. But before we can do that, we have to move head to the second node, because if we don't move head and we set this first node to null immediately, we lose this link and we won't have access to the rest of the nodes. These nodes become memory leaks. And so let's go ahead and set head to currents next. And since we are traversing head, we're going to use a while loop. And what we're going to say is while you see this current in the picture, while currents next does not equal null. If that's the case, then that means there is a node that follows it. We're going to move head to that node, or we're going to traverse head to that node. So while current arrow next does not equal null, we're going to say asterisk head equals current arrow next. So again, to sum it up, this is what happened. Head was currently pointing at the first node, and we looked at currents next. Does it equal null? No, it doesn't. So we traverse head to the next node. Now we are in this situation. We can set currents next to point null, but in order to reverse this entire list, we are going to need more than 2 pointers. We're going to need a third pointer. we are going to manipulate our pointers. And so let me create another pointer, and we're going to call this pointer previous because it's going to be the previous node before current. And right now we're going to set previous to equal null. All right, so let's code that. Create a node pointer, and we're going to call it previous, and we're going to set that to null. Now that we have our previous set equal to null, we can then set current's next to equal to previous. So what happens when we set that equal to previous is this link now is completely broken. And this is what our diagram in a heap looks like so far. But just because the link is broken, we still have access to index 1, 2, and 3 because we traverse head to point to index 1. For our next step, we then want the previous pointer to follow current. So the way we do that is we just have to set current to previous. So when we do that, previous then points to the first node. But we still want it to be trailing head and current. That's why we called it previous. What we want to do next is we want to set current to follow head. So we want to set the address of head to current. So current follows head. And for the most part, what we have here in our while loop is pretty much the algorithm. So let's trace it. After current follows head, we go back to line 55. While current next does not equal null, well, no, current next does not equal null. It equals 0x300. So if that's the case, we want to traverse head to the next. And then we want to set current's next to previous. So let me fix the addresses. This becomes null. And this becomes 0x100. And this link is now broken. But we still have access to all of our nodes because head is pointing to index 2 and current is pointing to index 1. And I'm talking about the blue indexes. After we set current's next to previous, we then set current's address to previous. So that means previous follows current. After that, current follows head. So we set head's address to current. We then go back to line 55. Current's next does not equal null. Is that condition true? Well, current's next holds 0x400. So that condition is true. We then traverse our head to current's next. So our head moves to the next node. After our head moves to the next node, our current's next pointer is set to previous. So this is set to this, and this now holds the address of 0200. And this link is broken. We then go to line 59. Current's address is set to previous, so previous follows current. We then go to line 60 and current follows head. We then go back to the while loop condition. Current's next does not equal null. Well, current's next does equal null. So if that's the case, we break out of this loop. And once we break out of this loop, all we want to do now is set current's next to previous. So let's go ahead and do that. And we have to do it outside of the while loop here because after current's next became null, we break out of this while loop. So now we're going to set current arrow next and set that to previous. So this now becomes 0x300. That's pretty much our algorithm. But there is one more thing that we have to do. What if we have a condition where, here I'm going to draw it here at the bottom, our head node is pointing at null. So we still have to address that. But that's an easy fix because if that's the case, we just want to print the list as empty and exit. So let's do that before the while loop. So we want to say if asterisk head equals null, then we just want to printf the list is empty versus not possible. Semicolon, and then we just want to exit the function. Let's compile to make sure I didn't make any errors. And we should still have that printing. Okay, good. So now let's test this condition. Here, I'm going to call reverse list. And inside, I'm going to give it the address of head. But let me print a new line here. And then after reverse list function is called. And then we're going to print it again. Okay, let's run it. Let me add a semicolon. Okay, let's run it. And there it is. And let me fix our formatting real quick. Okay, so the very first time on line 44 it printed the list, it printed the regular condition, 10, 20, 30, 40, and there's 4 lists. After we reversed the list, it printed 40, 30, 20, and 10. So our function worked. Let me add a 5th node and let's run it. Okay, there it is, 10, 20, 30, 40, 50. Number of nodes 5, and then after we reverse the list, we have 50, 40, 30, 20, and 10. And notice how the indexes are completely opposite. Index 4 is now index 0, index 3 is now index 1, and so on and so forth. Okay, now let's test our condition of head is null. So let me comment these out. The list is empty. After the reverse list function is called, the list is empty, reverse is not possible. So our conditions work. Let's do it one node. There it is, index 30, number of nodes 1, after a reverse function is called, because it's only one node. So let's do it with 2 nodes. 20, 30, 2 nodes, 30, 20. And finally, let's do it with 3 nodes. And there it is. Now there is another way to write this function, and the other way is we can return the address of head. So let's create a reverse list 1 function that is a return address. This is a call by address, and now let's do a return address. And again, the modification is really simple. So this is going to become a pointer. We only need 1 here, and once I get, and let me put a 1 right there. And I'm just going to copy this function and I'll put it right below it. And so let's make some changes. So let's make this a pointer. This becomes a single pointer. Anywhere you see an asterisk on head, they disappear. And then finally, we just want to return the address of head. So this is a return the address. And so here, when we call it in our main function, we're going to say head equals reverse list 1. And then we're just going to pass it the address of head, and let's run it. Oh, I forgot to put the 1 right here. Now let's run it. It reversed it. So let's do it with 2 nodes. Let's do it with 1 node. Let's do it with an empty list. The list is empty, reverse is not possible. And finally, let's do it with all 5 nodes. And there it is, the function is reverse. And so briefly, let me explain what's going on here. What's happening is our head, this head right here will have an address. So let's just say that has an address of 0x50. And our head in the main function, let's just say this is the main activation record. The head here will have an address of 0x20. So what happens when we call it, we're really returning this address. So this really, since head is an address variable, we're just setting it to that. So this head right here becomes this head, and that's what's happening here. And that's it for our reversing our linked list. Thank you.